Hey everyone, I want to take a look at a binomial distribution problem. This one's got a lot going on, and I think it will help us to see how to do the binomial distribution, whether you want to do it by hand, which I don't recommend, or if you want to use a Google Sheet or an Excel spreadsheet as well as an online calculator. And there's some pros and cons to each of them. But let's take a look at a problem and recognize why this is a binomial distribution. Here we're talking about an airline that has planes that hold 15 people. But they realize that when they sell tickets, 20% of the people are not going to show up. So they don't want to send a plane out with empty seats. So they overbook flights. They overbook them because they know that there is a chance that people won't show up. And it's going to be some sort of risk-reward kind of comparison. And I'm sure they did a lot of studies to figure this out. But we're going to take a look at this problem right here. It says, if the airline decides to sell 18 tickets for this flight, how often will there be at least one person who will not get a seat? Which means that I'm selling 18 tickets. How often are 16 or more people going to show up? Because if 15 people show up, everybody gets a seat. If 16 do, then there's one person that doesn't have a seat. So you're going to realize that when you're looking at these problems, it's a lot about trying to define and understand the context, understand what it means to have success or failure. So I'm gonna use and show how it would be set up in order to do this by hand. And in order to do it by hand, it shows us and reminds us here this combination formula. Because when you say, I've got 18 people and I'm going to choose 15 people out of there, how many different ways could it be those 15 people, right? It could be Bob, Mary, and Sue. It could be Bob, Mary, and Jim. It could be Bob, Mary, and Andy. There's lots of different ways to choose the group of people, who doesn't show up and who does show up. Furthermore, it's a combination because it doesn't matter which order they show up. If it's Bob, Mary, Sue that are on the flight, that's the same as Sue, Mary, and Bob on the flight. Order's not important. So this first part of the binomial distribution is simply counting how many ways can this happen, right? In this case, I am going to be taking this idea and I am going to say success is you show up. Which means there's an 80% chance that you show up for a flight. So that's how I'm going to base when I'm working through this. I'm going to say in the first part that I want to know how often are 16 people going to show up, because then somebody's gone. So I'd have to say 18, choose 16 of them, right? If 16 people show up, someone doesn't get a seat. How many different ways can that happen? I'm going to multiply that times the probability of success. The probability that 16 people show up, well, there's an 80% chance that each person shows up, and I want 16, right? So it's kind of like going back to the original thing and saying, here's the 80% times 80% times 80%, as you're going through this and doing it 16 times because you're counting, right? It's the fundamental counting principle. So I've got 16 people that show up, and then there's also a 20% chance that 2 people won't. So you're going to notice when you look carefully at this idea that it's the probability of success and how many successes, and then it's the exact opposite, the complement. It's the 1 minus that. So there's 20% chance that they don't, and how many people don't show up, right? This would give me exactly 16 people. So if I wanted to know what's the probability that 16 or 17 or 18 show up, I would have to take all of this work and add 18 combinations of 17 times 0.8 to the 17th times 0.2 to the 1st. That's 17 people show up, plus 18 choose 18. Again, 0.80 to the 18th times 0.2 to the 0 power, which ends up being 1. But I'd have to add all these things together. This is 16 or 17 or 18 people show up. This is where, at first, it's kind of nice to have a calculator. I use the online calculator that is at StatTruck. So I'm going to grab that and show the nice part about this calculator. It's the binomial probability calculator. Probability of success, remember that someone shows up, is 0.8. 18 trials. I have 18 trials and I want to know how often 16 people are going to show up, right? And so I'm going to calculate that. And these results that you see here, here's the probability that exactly 16 people show up. Here's the probability that less than 16, less than or equal to 16. Here's the probability that more than 16, or the one I'm interested in, 16 or more people show up. There's a 27% chance that 16 or more people are going to show up for that. Now, going on, the idea is if you were to change some of these things and say, well, what if I only sold 17 seats? The nice part is you can enter that in and calculate it. If I sell 17 seats, there's an 11% chance that one person doesn't get a seat, right? If I sell only 16 seats, there's a 2% chance that 16 people or more. In fact, there's only a 2% chance that all 16 people would show up, which means there's a 97% chance that I'm going to have an empty seat on that flight. So this is the idea with a binomial distribution calculator. The only downside to this is you have to keep putting it in if you want to see all of them. But the positive side is it gives you all of the probabilities and you can interpret them based on what you are putting in as success and failure. The other thing that I have, I set up just to show a table because I can do that exact same thing in Google Sheets. For example, I can use the formula that is binomial distribution, and there's two ways to do it. I can say that I am selling, as I'm looking through here, I'm selling 18 seats and I want to know how often 16 people show up. Exactly. So that's 16 successes out of 18 trials. The probability of success is 0.8, and I'm going to say false because it's asking if it's cumulative. This is exactly 16 people show up. The other way to do that same thing is to do the binomial distribution and say 16 out of 18 people, an 80% chance, and I want true. That is up to 16. Furthermore, I can do a couple other things. Let's say I want to know less than 16, right? I can basically say, well, if this is less than and equal to 16 and this is exactly 16, if I subtract those, that is less than 16. What if I want to know greater than 16 or greater than or equal to 16? Greater than 16 is really 1 minus less than or equal to 16. So if I subtract this, there's an 82% chance that it's more than 16. Oops, I've subtracted the wrong one. Minus that. That's greater than 16. What if I want greater than or equal to 16? I can find the complement of less than 16, and that's greater than or equal to 16. So it's important to recognize how these things kind of get to put together, like when you're less than or equal to, greater than or equal to, or exactly. The advantage of doing this in a Google Sheet is that I can do this once and then kind of put all this together. So what I have over here is I have determined how many people I want to show up. There's 15 seats, so I want to know when 16 people show up. And this is going to be out of how many tickets I sell, right? So some of these are going to be really stupid. Like you can't do it for anything less than 0. I just put it in here to show you that I could go through and say, here is a binomial distribution. And I am going to say, I want to know how often are 16 people going to show up. So I clicked on the 16. I'm using the F4 to lock in that number 16. 16 people show up if I sell 0 seats. I want this to be based on the 80%. And again, I have the 80% here, so I'm just going to click on it, lock it in, and I want this to be exact. Now this one, it's going to yell at me and say, that's not possible. When I go down, none of them are possible until I get to 16, right? There's a 8% chance that 16 people. Now the nice part is I could extend this and continue to do this. Like what if I sold more seats? I could take this and drag it down and understand all the way up to 25. What's the probability that exactly 16 people show up? Right? What is the probability that 16 people or less show up? It's basically the same thing that I had here. So I'm going to paste that in here, but it's true. That's less than or equal to 16. And again, this is all the way up to 16, less than or equal to 16 people show up, right? If I wanted less than 16, then I am going to basically say, well, less than or equal to minus the equal to. So this minus this, the probability that less than 16 people show up. More than 16 people show up, remember, just like we did over here, equals 1 minus. And it's 1 minus. If it's greater than 16 people, 1 minus less than or equal to 16. And 16 or more, that is going to basically be 1 minus less than 16. And so I have these formulas set up. I could take all of these things and just make them show them to me as a percentage if I wanted to do that, do some other things to see it. But this is the advantage of using something like Excel, is I can see all of those probabilities and say, if I sell 19 tickets, there's a 21% chance that 16 people exactly show up. There's 76% chance that's 16 or less. There's a as far as not having a seat, and you could do all these, I could change this to say, let's just look at it with 15 exactly. Like, I have 15 seats. What's the probability that I get exactly 15 people to show up? What's the probability that I get more than 15 or less than 15 to show up? Greater than or equal to, less than or equal to, and you can use those to make whatever decisions you have. All of these things based on the idea that this is a binomial probability. Really, a binomial distribution is what we're taking a look at here. This is a distribution because I have the number of successes I'm looking for and the percentage for each one of them, and I have lots of ways to report that. Don't always need all of them, but it's there in case you do.